We have the quadratic inequality x squared minus 5x plus 6 less than or equal to 0. We want to solve for all x. So let's first factor this. We get x minus 2, x minus 3. And so you're going to set each one equal to 0 and get x equals 2 and x equals 3. So now we need to test the regions. So we pick a value to the left of 2, let's say 0. Plug it in here, you get negative 2 times negative 3. That's going to be positive. Pick a number between 2 and 3, say 2.5. Plug it in. This is positive, this is negative. Positive times negative is negative. Pick a number here, say 5. This is positive, this is positive. Positive times positive is positive. For this question, we're looking for when this is less than or equal to 0. So that's going to be in this interval here between 2 and 3. And you want to make sure to include 2 and 3 because that's where the quadratic is equal to 0. Okay, next example. We're given a long polynomial, x minus 2 squared, x minus 4, x plus 13 raised to the 17th power, x squared plus x plus 1. And we want to see when this is greater than 0. Well, we have to set each factor equal to 0. So we get 2, 4, negative 13. And this you cannot factor. There's no nice solution for this, no real solution. So we're going to just ignore this. Now we're going to plot in the points, negative 13, 2, and 4. And plug in values here. So let's say something less than negative 13, let's say negative 20. We know that this is always going to be positive because any number squared is positive unless you put in 0. I'm sorry, unless you plug in 2, which we're not going to. So we can ignore this. Now, negative 20 minus 4 is negative. This is also going to be negative. So it's negative times a negative, and this is, let's see, 400 minus 20 is, 380 plus 1 is 381. So that's a positive. Negative times positive is a positive. Pick a number between negative 13 and 2. Let's say 0. We said it's always positive, so we're not going to bother. So this will be negative, positive, and positive. That means it's going to be negative. Pick a number between 2 and 4. Let's say 3. So here 3 minus 4 is negative. 3 plus 13 to the 17th is positive, and then that's also positive. So that's negative. Pick a number that's greater than 4. Let's say 5. Positive, positive, positive. Okay, so it's all positive. We're looking when this is strictly greater than 0. So in other words, when it's positive, that means we're going to be in these two regions. So when x is less than negative 13, or x is greater than 4. And make sure to not include negative 13 or 4 because that's when it's equal to 0. Last one, we have a rational function. The numerator is x squared minus 16. Denominator is negative x squared plus 5x minus 6. We want to see when this is less than or equal to 0. In order to do this, you want to factor the top and the bottom. Get x minus 4x plus 4. And then negative x plus 3, x minus 2. Set each one of these factors equal to 0. So you get 4, negative 4, 3, and 2. Now we're just going to test the different regions. So pick a number that's smaller than negative 4. Let's say negative 5. Okay, so this one is a bit of work. So we have negative 5 minus 4 is negative. Negative 5 plus 4 is negative. Now negative 5 is positive 5 plus 3 is positive. Negative 5 minus 2 is negative. So this is, well, negative times negative is positive. Positive times negative is negative. And so positive divided by negative is negative. Okay, so this whole thing is negative. Pick a number between negative 4 and 2. say 0. So we have negative, positive, positive, negative. So this is going to be positive. And pick a number between 2 and 3, say 2.5. Get negative, positive, and then positive, positive. So this is negative. Pick a number between 3 and 4, say 3.5. We get negative, positive, negative, positive. So this is positive. And then pick a number greater than 4, let's say 5. Get positive, positive, and then this is negative and positive. So this is negative. Now we're looking for when this is less than or equal to 0. So you want the negatives basically. So it's basically all of this. This is negative. And then this is negative. So you want to include the endpoint since it's less than or equal to 0. So we get negative infinity to negative 4, union 2 to 3, union 4 to infinity. And this is our final answer.